Hello everyone and welcome to Fatal Sec. Today's video is going to be on understanding and bypassing various jailbreak detection techniques on iOS. For the demonstration, I am going to use a vulnerable iOS application called Ghidra. It is primarily developed to showcase OS top 10 risks, but it also contains some in-app protection techniques such as jailbreak detection, anti-tampering detection, and debugger detection. So for this video today, we are only going to look into the jailbreak detection. So the sample application, you can download it from here. I have mentioned the link in the description box as well. Okay, but before getting started, let me put this out. If you have a Mac machine, then it would be easy for you to connect to the iOS device and install the application directly via Xcode. But in case you don't have the Mac machines just like me, then don't worry, you can still perform the pen testing of an iOS application. All you need is to configure some additional tools. Now, I am not going into the details of this, but if you are interested in how to set up the Linux environment for iOS app pen testing, then do let me know in the comments down below and I will make a dedicated video on this topic. So without wasting any more time, let's get started. One more thing, I have attached my iOS device. I am sharing its screen via AnyDesk. So here you can see that the device is connected and its screen is being shared so that you can see what's going on the device itself. Now, as you can see, it has this uncover application installed, which is our jailbreak application. And if you open it, it will show that the device is already jailbroken. Okay, so let me show you quickly what this DVI application is. And by default on the landing page, it shows your device information. Then there is this top left menu. And by clicking on that, we can see various functions which this application provides. So like I said, it is mainly developed for OS top 10 risk, but it also has jailbreak detection functionality. So let's click on the jailbreak detection and then we can see that it has various tests available to detect whether the device is jailbroken or not. So when I click on the jailbreak test 1, it says that the device is jailbroken. Similarly, for jailbreak test 2, it says device is jailbroken. So our goal here is to make application think that the device is not jailbroken, and instead of this dialog box should say that the device is not jailbroken. Okay. Now I have the IPA file already downloaded in my working directory, which is documents trainings 2023 iOS. So here I have the IPA file. So the first thing here is that we cannot directly start analyzing this IPA file because it's actually a zip package, just like the APK file format. We have to extract it first, and to do that we can simply use unzip command and provide this IPA file, hit enter, and it will extract all the artifacts, assets and binaries from this IPA file. Now if I list files, we have this payload directory created, and if we go into this payload directory, we have devia v2.application, and it's also a directory, so we can go inside it and now list the directories again, and we have all the files, artifacts and assets from this IPA file. So the one we are interested in is actual binary or the actual executable file, which is this one, devia-v2. So in order to better analyze it, it's better to list all the attributes of the file. And now you can see that here we have this devia v2 application, right? So just to see the file type of this file, we can use file command devia-v2, and it says that it's a Mac OS 64-bit ARM executable, right? So now we have the actual binary which we have to analyze. This time, instead of Radare 2, I am going to use Ghidra just to have some variety with our disassemblers. So I have Radare opened already here. So let's import this executable file via import file. And here is our devia-v2 executable binary. Select file to import. Okay. And now it's just importing this executable, processing all the required headers. Okay, so the basic analysis is done by this Ghidra tool. Let's hit OK. And if we double click on it, then it will actually start disassembling this executable binary. And it's saying that the binary has not been analyzed. Would you like to analyze it now? Hit yes. You can leave all these as it is and click analyze. Now it will take a couple of minutes depending on the size of the executable. Here you can see the progress. It's currently trying to decompile and disassemble a lot of functions which are present in this binary. Alright, so the analysis is done by Ghidra, and now we can start looking at the symbols. For that we can go to the window tab and click on this symbol table. Over here there are a lot of symbols present in this application. I think there are more than 30,000 symbols identified by Ghidra. And this is very overwhelming for us to look into all these symbols, and if we try to go through them one by one, it would be very challenging for us. Since our goal here is to identify and bypass the jailbreak detection, so let's filter out the results based on jailbreak keyword, which we can do simply by typing jail over here, and now it's showing only the symbols having jail as a keyword. Now let's scroll to the top and see what all symbols we have. So at the top, we can observe some Objective C class related symbols, and then these symbols, these are actually the Swift symbols in a mangled form. Generally, when we compile the Swift application, the compiler mangles all the symbols, which is called Swift symbol mangling. And the compiler uses this option to ensure type safety and enable features such as function overloading and polymorphism. But still, it's not very hard to understand what the symbol is. For example, over here, if we remove this underscore T07, we can see that it's coming from Devia underscore V2 application or framework. Then ignore this 32. Then we have jailbreak detection view controller, which is the name of the class. Then the name of the member inside this class. So in a similar way, you can understand all these symbols, but since these are coming from the view controller, we are not going to look into them, because in iOS, view controllers are the parent of the views present on the storyboard. Or in other words, view controller is a container in the storyboard on which the content views are drawn to create an iOS application. Okay, so most of these view controller related symbols are just for the UI part, and we are looking for the actual function where the business logic is present, so that we can understand the jailbreak detection logics used in this application. Let's scroll down a bit, and over here we have jailbreak detection underscore is jailbroken function. This looks interesting. Let's click on the location and minimize this window. Now in the disassembly, we can see the disassembled code of this function. Now this function looks like where all the jailbreak detection logic is implemented. On the right side, you can also see the decompiled version of this disassembly. This is done by Ghidra automatically. So immediately, if you look into the signature of this is jailbroken function, or even by the naming convention of this function, it says is jailbroken, means it's either returning true or false. And Ghidra also was able to identify this and represented the return value as bool here. So as an attempt to bypass this jailbreak check, we can simply try to hook this is jailbroken function, right, and manipulate its return value to always return false. This will make the application think that the device is not jailbroken, but this would be very easy to do. And the goal here is not just to bypass the jailbreak detection, but also to understand the logic behind it. So let's dig a bit deeper into this function. So in the disassembly, we can observe a couple of interesting symbols like NS file manager, followed by fileExistsAtPath, followed by a string represented, followed by a string slash application slash cdr.app. Then yeah, so let's try to, so if we try to make some sense of this disassembly, we can say that here it's trying to call this fileExistsAtPath method of NS file manager class, and as the argument it is passing this slash application slash cdr.app, which is a path where CDI application is present on a jailbroken device. If you don't know, CDI is the kind of a package manager which is present on mostly all jailbroken devices to install third-party applications or tweaks which require root permissions. Then moving on into the disassembly, after this function call, we have a branch instruction to this block. Okay, so Ghidra also provides us the option to see the control flow graph of the function, which we can see simply by clicking on this display function graph button from the top menu. So if we click on it, it will generate the graph. It looks quite interesting. So here we are in the first block of this function, where we just saw that it's trying to call this file exist@path and taking application slash CDI as the argument. And then it's taking some decision based on this instruction, right? So this is test bit 0, which is the ARM64 instruction, since we are dealing with the ARM64 based binary. What this instruction basically do is it will test the 0th bit of this W10 register, and if it is clear, then it will take this branch, otherwise it will continue executing the instruction which is present here. And also if we see right after this file exist@path, which gets called and its return value is stored here using this LDUR load register instruction basically. So based on this analysis, we can assume, or it's safe to say that if this cdr.application path exists on the device, then this W10 register will be true, and then this instruction will be forced to take this branch instead of this. Okay, so now we know at this point that this file exists at path function is responsible for one of the jailbreak detection. So let's try to intercept this using Frida, and for that I am going to open Visual Studio Code, and I am already inside this iOS directory where our IPA file is present. So let's create a new script and name it as script1.js. Okay, so first of all, we need to make sure that our Objective C classes are initialized. To do that, we can make use of a if condition, and inside this we can check using objc.available. This is provided by Frida itself, so we don't have to import anything for this. Then in order to attach the hook, we have interceptor.attach API of Frida, which I assume you guys are already aware about. Then inside this, we need to pass the function name, right? So first of all, we need to provide the class name, which is ns file manager, and for that again we can use objc dot classes dot ns file manager. Okay, the methods from this ns file manager can be accessed via an array, so let's do that. And over here inside double quotes we can provide the name of the method, which is file exist at path followed by a colon. So this is just the convention in which we need to provide the method name. Once we have the reference to the method object, we can use the implementation keyword and then the body of this interceptor. Inside this body, we can make use of either on enter, which takes one argument, and another member of this interceptor is on leave, which takes one argument, which usually is the return value of the function. So let's name it as return value, then the body of this. Okay, so what happens now is whenever this file exists at path is called, on enter will be called first, and when the execution of on file exists at path is completed and when it's about to return the value, this on leave function will be called. So here we can intercept the return value returned by this file exist at path method, and inside on enter we can intercept the arguments passed by the application. So let's see what the actual syntax of file exist at path is. So if we open up our browser and search for this Apple developer documentation, it says that it returns a boolean value that indicates whether a file or directory exists at the specified path, right? And here's the signature of this function. So this is the return value and this is the argument, and it takes only one argument, which is path of type ns string. Okay, and if we look into the ns string data type, it's a plain text Unicode string. This is useful because using Frida we need to read the value of this argument, so we have to know about what type of data is being stored. Coming back to our script, so now we know that it only takes one argument, but when hooking Objective-C methods with Frida, the method signature typically includes two hidden arguments. First one is the self argument, which is basically the instance of the object, and the second one is the CMD argument, which is a selector which identifies the method being called. And then finally, as a third argument, we have our regular argument passed to the method, which is the path in this case, and that's why we have to use second index of this argument. So now let's simply put a log and print the argument of it. Let's take the argument in a variable called path, and like I mentioned, the data type of the argument is ns string pointer, so we have to convert it into the respective format. And for that again Frida provides us this objc, and using this we can create an object which is our argument 2, and then we need to convert it to the string format. Okay, so now this path we can simply put here. Let's save it, and similarly inside on leave, let's observe the return value. So here these plus and minuses are just for the reference in the console, so that we can identify which one is on enter and which one is coming from on leave. So here the return value I'm going to print simply like this. Now let's try to run the script, but before that we need to know the package name. So the package name you can also identify by looking into this info.plist file. But for now, since our Frida is up and running on the device, we can simply use Frida ps-uai command to list all the running processes, and over here we have this dvia application and its package name is this. So let's copy it, and now here we need to go back to directories because that's where our script is, right? And now let's launch it using frida-u to specify the USB mode, and then -l to list the script we want to attach, followed by -f to forcefully spawn the application. Lastly, we need to pass the package name, which is this one. And now when we hit enter, it will spawn a new process and attach our script to one. Let's hit enter. So on the device, the application is launched, and in the console log, we can see that fileExistsAtPath being triggered multiple times just on the landing page. And here you can observe the arguments, which are mostly the artifacts or the assets inside the application, which we saw after extracting the IPA file, right? So we don't have to bother about these. Let's come down, and in the application, let's go to the jailbreak detection because that's where we want to observe the behavior of this fileExistsAtPath method. And now if I click on this jailbreak test 1, we should be able to intercept the method. And in the console now we have fileExistsAtPath with the path as application/cdr.app, which we saw in the Ghidra disassembly, right? This one. So this confirms our analysis also that during the jailbreak detection is jailbroken function is being called, and inside that is jailbroken function, it is trying to call fileExistsAtPath with this argument, and the return value is 1. Now in order to bypass this, there are a couple of ways. We can either manipulate the argument which is being passed over here in this method with some fake path, or we can simply manipulate its return value to always return false. So let's try to do that by going back to the script, and let's make some conditions here. So if this path is having cdr.app, then we should replace the return value over here. So we have to make a variable, and for that let's create a variable called, let's say, jailbroken, and initialize it with 0 initially. And if the path contains cdr.app, this means that the application is detecting it as jailbroken. So let's change it to 1. So here it's acting like a flag. By default it's 0, means the application has not yet identified any jailbroken artifact. As soon as it detects the artifact, we are changing it to 1. Okay, this variable we can now access inside this onLeave method. So if this dot jailbroken is equal to 1, then only we need to manipulate the return value, right? So let's do that. Manipulated return value, and to manipulate it we can simply put return value dot replace. So we can create a new native pointer and pass 0x0. So yeah, let's save the script and go back to our console, reload the script, and on the application let me trigger the detection again. Yes, in the console it can be observed that the fileExistsAtPath is triggered and the return value is manipulated to 0 now, right? But immediately after this check, we can observe a couple of other calls being made to fileExistsAtPath with different file paths like mobile substrate, binbash, sbinshd, right? But before attempting to bypass these checks, let's analyze it in the disassembly as well. So going back to the Ghidra, instead of looking into this disassembled code, let's visualize it in the graph view because it's easy to understand and analyze it from here. So what happened so far? fileExistsAtPath method got triggered with cdr.app as the argument. Since it is present on our device, because of this instruction in our W10 register, the 0th bit is set, because of which instead of going to this basic block, it was going to this one and showing the pop-up on the UI saying device is jailbroken, right? But since we manipulated the return value returned by this method to 0, so this W10 register is now containing 0, making this condition to go to this basic block, right? So now we have to analyze this basic block, and inside this basic block again we can observe that this fileExistsAtPath method is being called, but this time with some different file path. So here it's not showing the full path, so let's minimize it, and over here we can see it's trying to this library mobile substrate. So this is the same which we saw in our output, right? And if this path exists on our device, then again at the end of this basic block we have this test bit on 0. So based on the return value of this fileExistsAtPath method, it will decide whether to take this branch or this branch. But if you observe from the output for mobile substrate, it's already returning 0. This is because on the device I don't have this mobile substrate library installed. That's why we don't have to bypass this check. But on your devices, if it's returning 1, then you know what you have to do, right? And for the sake of explanation, let me also add this condition in the script. So just like what we did for Cydia app, we can put another condition like this. And over here, we need to check again for the path. And if it contains mobile substrate dot dyld, then we need to set this jailbroken flag, so that in the return value it will be modified to 0, right? Saving the script. For me it's not going to make any effect because for me it's already returning 0 for mobile substrate file path, right? Similarly, in the output we have bin bash, and the return value is 0 because I have not installed any kind of terminal on my jailbroken device. But if you have installed that, or if you are using a different kind of jailbreaking technique, then this might get installed by default, which will result in the detection, and as a result you will get return value 1. So since there are a couple of different file paths being checked by this is jailbroken method, so what we can do is, instead of like putting these conditions one by one, we can create a set of array and pass all the paths over there, and then iterate on that array to decide whether we need to modify the return value or not, right? But before doing that, let's quickly analyze the same thing in the disassembly. So over here we have the mobile substrate, and if it is present on your device, then it will take this branch and immediately show that the device is jailbroken. Since it is not there, it's coming to this block, and over here again we have fileExistsAtPath, but this time it's trying to access bin bash, which is what we observed from the output as well. And since this path is also not present on the device, instead of going to this block, it's coming here and checking again for a different file path this time, which is usr has been sshd, which is this one, and on the device I have it's returning as 1. And again, if we move forward after this file path check, there is going to be another check using the same method fileExistsAtPath, and it's checking for /etc/apt. So this will get triggered as soon as we bypass this check, right? So let's try to bypass all these file paths. Now instead of putting these file paths one by one in if else condition, I am going to make an array on top here with the name paths, which contains all these paths which are cydia.app, then mobile substrate.dyld, then /bin/bash, then /sshd. We don't need to put the whole path because we are only comparing it with the substring. Then the last one was etc/apt. Okay, right? And now after this we can simply iterate over this using a for loop. Let I equal to 0, I is less than paths dot length, and I plus plus. Inside this we can put the condition if path dot index of contains any one of these paths, then it will be considered as jailbroken. So we are setting our flag, and then on leave it will automatically manipulate the return value. No need of this now, and we should be good to go. Also we can put a break condition here, so as soon as any one of these condition is met, we don't have to iterate further. Let's save the script, going back to the terminal, reload the script using %reload command, coming back to the application. Let's trigger the jailbreak detection check again, and what do we get this time? Firstly, Cydia file path, which is manipulated to 0, then mobile substrate, which is already 0, so no need of manipulation. Similarly for bin bash, return file path return value is 0. Then for sshd, its value is manipulated to 0. Nice. So like I mentioned, once this condition is bypassed, the next check got triggered, which is /etc/apt, which we have seen in the disassembly right over here, and that one also got manipulated to 0. So after bypassing all these file paths, still the app is complaining that the device is jailbroken. So there is still some other checks present which we have to bypass. So going back to the disassembly, and over here, once this check is bypassed, so based on this test bit 0 instruction, our W0 register is now containing 0 because we have manipulated the return value to 0, and that's why it will take this branch this time. Okay, so we can simply come over here to this basic block because that's how the flow is going. And inside this block, this time we have some other method which is write to file. Let's see, it's not visible entirely what the function is. So when you click on it, it will automatically be synced in the disassembly view. So if we go inside the code browser, this time it's trying to call write to file atomically method. Okay, this is something new, and it's taking this file path as the argument /private/jailbreak. Okay. Also, the method name is not entirely visible here. We need to know the entire function name or the method name in order to attach the hook. So if you just hover over this symbol, it will show you this small pop-up window where this entire symbol is present. Also, by double clicking on this, it will take you to that place, and here we can observe that it's write to file atomically encoding error. Again, it's abbreviated here because I have enlarged the font so that you can see it clearly. So let's see what this function actually do. So if I copy this, go to the browser and Google about this, the first link we have is this write to file atomically error encoding by Apple, and here it says it writes the content of the receiver to a file at a given path using a given encoding. Okay, and this is the signature of this, so it returns the boolean value and it's taking ns string pointer path as an argument. So now we know the signature of this method, and also here we can see that it's coming from ns string class, right? So now we have all the information we needed to write the interceptor. So let's copy this. Instead of typing everything again, paste it. Instead of ns file manager, it's going to be ns string, and instead of this file path, it's going to be write to file path, write to file atomically encoding error. So now in the console logs, let's just replace these. And since the first argument to this write to file method is the path, we don't have to change anything over here. And for now, let's just intercept the arguments. Similarly, on leave, let's just see the output. Saving the script, going back to the console, and we can reload the script. Coming to the application, clicking on this jailbreak test one again. And now in the output, this write to file method is triggered, which is containing /private/jailbreak.txt, but the return value is 0, which suggests that it's not able to write this jailbreak.txt file to this path. So we don't have to bypass anything for this. But if on your devices it is returning 1, then you know what you have to do, right? Just replace the return value. And just for the sake of the script, I'm going to do that over here. I'm going to put it in a if condition directly like we did. So let me copy this and paste it here. Instead of this, it's going to be jailbreak.txt. Then we have this dot is jailbroken, which we have to initialize it to 0 initially. No need of this break statement now. And let's replace this fileExistsAtPath with write to file. Okay, cool. Inside on leave, we just need to copy and paste this. So now whenever this write to file method tries to write any file containing jailbreak.txt as the file name, it will be considered as a part of jailbreak detection technique, and then inside on leave, based on this jailbroken flag, our script will manipulate the return value to 0. So coming back to the console, we saw that its return value is already 0, but still the app is complaining about the device is jailbroken. So what else is being detected? Let's see. Coming back to the function graph inside Ghidra, after this write to file method check, it's coming to this block. So again, in this time, instead of test bit on 0 instruction, we have cbnz instruction, which is compare branch on non-zero. So if x8 register contains 0, then it will take this branch, otherwise it will come here. So since this write to file method is returning 0, it's going to come here, and inside this what do we have? So we have a new method which is remove item. Just to see the full method name, it's remove item at path. Okay, so here it's just trying to remove the file which is being written in the previous block using write to file method, right? So this is not involved in the detection, but it's just cleaning up the mess. Then moving on, we see some UI application related stuff. And then we have URL with string, trying to call this with this argument. Okay, so yeah, now in this block it's trying to call URL with string file path, and then it's trying to call canOpenURL. Okay, so this canOpenURL method is taking this Cydia package URI as an argument. So let's first of all see the signature and the definition of this method. Again, going back to the browser, and let's Google about this. Going to the Apple documentation, it returns a Boolean value that indicates whether an application is available to handle a URL scheme. Okay, so it's a function taking URL as an argument and returning a Boolean value. So again, this URI, which is cydia:// is only available on the jailbroken devices. So let's try to intercept this canOpenURL method first. Again, copy and pasting this, and instead of write to file, we have canOpenURL, right? Let's replace it over here. No need of this as of now. No need of this because we are just trying to intercept the values. Again, the first argument of this is the URL, so no need to make any changes in the argument. Saving the script, going back to the console, and it says undefined implementation. Okay, obviously, because this canOpenURL is not a member of NS string. Instead, it's a member of UI application class. So we need to change it to UI application. Saving the script, and now it's not complaining, right? So let's reload the script again. Going to the application this time, calling the detection check again. And now we can see our canOpenURL method got triggered with this URI as an argument, and its return value is 1, which is true. So now all we have to do is the same thing. We can copy paste this, and in the path, if it is containing Cydia, then it will be considered as jailbroken. And in the log, let's replace the method name, saving the script. So let's see now what happens. Loading the script again, and in the application, if I test for the jailbreak test, but it's still saying return value 0. Okay, I think I forgot to put this on inside on leave. So let's do that, saving the script and reloading it again in the console. And this time we can see that it's saying device is not jailbroken, and the return value is also manipulated to 0. Nice. And for all other jailbreak tests, it's actually calling the same as jailbroken function. So automatically all the jailbreak detection checks are bypassed for this application. If we click on the test 2, it says device is not jailbroken. Similarly for test 3, device is not jailbroken. For test 4, device is not jailbroken. And for test 5, device is not jailbroken. So all the jailbreak detections are bypassed now for this application. Now obviously when you deal with the real world applications, you may encounter other jailbreak detections as well, which are not implemented in this application, and the script which we have developed here does not cover all the use cases of jailbreak detection. And also along with some other jailbreak detections, sometimes you may encounter other challenges as well, like obfuscation and string encryption, which is not the case here, as we were able to see all the strings and the method names clearly in the disassembly, right? But now you know at least which methods are involved during the jailbreak detection, and you can try intercepting these methods during your security evaluation for jailbreak detection. That's it for this video. I hope you found this helpful, and if you did, please consider giving it a thumbs up and subscribing to this channel.